Okay, we're in section 8, 0.4.1. That's the related Sage code. And again, for those students that want to use what I call the low bar of using Sage, you just click on this link over here, which will bring you to the Sage Math website, and then you can use the CoCalc. The only real difference between using the web version and one on your computer is the web-based version, you're using somebody else's computer to do the computation. And they, for the most part, if you're trying to do something really big, they're just not going to let you do it, or they're going to take a really long time to get it done. So I like to run it on my own computer. And that's why I use what I call a terminal application. And that's something, particularly if you're going to STEM, you probably should learn how to use. All right. So let me go back to my terminal and I'll type these commands in. And as I do that, I want to emphasize they mean something to me. For example, clear, what that means is they're just going to clear the screen. Nothing happened, by the way. It cleared my screen. All right. So if I had a lot of things down over here, including a bunch of error messages like this over here, and I type in the clear, what it's going to do, give me a nice clean screen. And that's nice to know. So if I have a lot of things that are disturbing me, I can clear the screen. It's not doing anything else but that. It's only clearing it. What does reset do? It's completely different. Reset is basically purging any information that Sage is holding reserved for me. Like if I define variables or functions, it's clearing it out for me. A clean sheet of paper. What I'm going to do now, X of variable. And you can try copy and pasting, but unfortunately, a lot of times with copy and pasting, I hope you realize that if you're studying computer science, a lot of students do copy paste code, which is probably something you shouldn't be doing. You should be trying to code on your own. By the way, that's a tough skill set to acquire, good coding. That's why so much code is copy pasted. I mean, some code is so well written, it's kind of hard to write a better version of it. So it can't hurt to, do a copy paste of that kind of stuff. All right. Okay, let's keep going. And code is reusable, by the way. That's what we're doing over here. So I'm going to, look at this one over here. It looks kind of crazy. My concern is I'm wondering, is this related to anything that we've done before? Like square root, and then they got this, 1 plus. Well, I bet this has something to do with a problem that we've done prior. So I'm going to look for that. And I go back to the beginning. I think it's over there somewhere. Yeah, there's long notes, right? Again, if you have a textbook, the textbooks are really long. All right. We really had kind of cut all the stuff out. And I think it might be this one over here. Yeah, it's this problem here. Right. You remember that. The first problem we did. All right. And a graph of and everything. That's fresh in my mind, by the way. It's fresh in my mind. That's what f of x is. I'm scrolling back to the Sage code. And again, we're just learning how to use a computer algebra system and, play around with it. You can play with as much you like. If it's all in your computer's the one that's doing the work. All right. So I'm going to type this in now. I want to point out this will cause an error. Again, I want to emphasize the reason it causes an error. It's the quote marks. All right. It says invalid syntax. It's even pointing it out to me. If you notice over here, it's pointing out where the error is. Type that in again, proper quote. That's an artifact of copy paste, by the way. It says it's 0. All right. So I'm going to start defining things now. I'm going to say P1 is a plot. So what's this P1 going to hold? A graphic primitive. And I want to graph the primitive f of x, right, where x is between 0 and 5. Now, you notice in the past I put down x min, x max. All I'm saying is Sage is a variety of ways of taking input. Okay. I'm going to put P2 down now. And again, this is an assignment operator, plot. And what I'm going to plot down is, we said there was a squeeze in this problem. This goes back to the very first problem. And that squeeze was 2 times the square root of x. I think you might remember me doing this. And x goes between 0 and 5. Again, we're just typing. And I'll tell you what these things give me. They give me another graphic primitive. So P1 is a graphic primitive. It's a graph of f of x between 0 and 5. P2 is a graphic primitive. It's a graph of twice the square root of x between 0 and 5. Now I'm going to put P3 down now. P3 is also a graphic primitive. Plot. And in Sage, at least on my computer system, that graphic primitive is a PNG file. All right, P3 square root of x. And that x is between 0 and 5. Oops. You're going to make mistakes by typing, just like if you guys are taking computer science, you realize a lot of times when you try to compile something, it doesn't work. All right. Now, what I'm going to do is I'm going to take P1, I'm going to take P2, and I'm going to take P3. So I'm taking 3 graphic primitives, and I say, could you combine them into one graphic primitive? And I want to show it. Now, before I do that, I want to tell you that I could just simply show P1. That was easy. I could show P2. Gee, that was easy. I could show P3. Gee, that was easy. And what I could do is I could show all 3. So let me go through that again with you. P1 plus P2 plus P3. Now, by the way, you might be upset with what it shows you, but the bottom line is I want to see what it does show me. And you're going to learn a lot by getting things not working as advertised. Well, you know what? That's not bad. That's what I was expecting to see. I was expecting to see, a graph with them superimposed on one another, where P1, P2, and P3 were on the same paper. And let's do this one over here. It's a limit problem. I think we might have done this one before too. It says it's 0. So I want to go back over the notes, and this is part of your learning curve, is to go back over the notes and start thinking about what we presented to you and what you've tried on your own. All right, what you've tried on your own. And we're looking forward to doing that. And the reason that we really do like to see success in our students, that is, they've done something and they're learning something. The worst thing that we're faced with is if you're not doing enough or you're doing so little, it just doesn't matter. And that's really heartbreaking to see that too. But anyway, looking back over the notes, I'm seeing something looks similar to this, right? This is x times cosine of 5 over x. Not the same thing, but it's similar. All right, you're scrolling back over. It's tough, we know that. Oh, it's right over here. All right. So, my bottom line is that we give you, a lot of work. We give you pictures and stuff. You may want to think, can you do that too? And I think you can. What I want to point out is I want to see if I can look at these guys over here and do the same thing I did before. So I don't even remember what you did before. Well, that's why we write notes for you. If you can't remember, you can do it again. Let's put this down. P1 is plot. Who knows? Maybe I'll make a mistake. It looks like, I don't know, the first graph looks like minus the absolute value of x. I'm going to say, I don't know, between -1 and 1. And again, this may not work as advertised. And that's upsetting for a lot of students. They say, if it doesn't work, what do I do then? Try again. I'm going to say P2. We can change this too. If it doesn't work, we can always change. X times sine 1 divided by x. I'm going to say x between -1 and 1. And I'll say P3 is plot, whoops, ABS x, and x is between -1 and 1. Again, don't be upset if things don't work as advertised. You're going to have that experience. And if you're taking computer science, I think a lot of code that you do doesn't work as advertised. And if you have a teacher that knows what code is and they're looking at it, they're going to detect immediately what's wrong with your code. The problem is a lot of people don't understand really coding. You look at something, they really can't find anything wrong with it or any errors when it's strewn with errors. All right. So what did we do last time? P1 plus P2 plus P3. We want to show it. See what happens. I'm seeing it. What am I seeing? I'm seeing the absolute value of X up on top. I'm seeing the absolute minus the absolute value of X on bottom. And I'm seeing that thing squeeze between it. I'm seeing a squeeze between it. You may want to zoom into these regions if you like. That's entirely up to you. Play around. We want you to play with software. The main reason is this: when you move forward, either at NJIT or another university, problems are going to get far more difficult, and you're going to need a machine to be able to do the problem. You are not going to get to the machine level unless you can do things by hand. It's just not going to happen, right? You need to learn how to do things by hand. That's why we spend so much time thinking through the process of what we're teaching. And we want you to spend an equal amount of time doing that. All right, thank you.